Hi class, today's lesson is lesson 12-5, compound events. Today's purpose is to list all the outcomes and find the theoretical probability of a compound event. Let's go ahead and start with our vocabulary. Vocabulary word or term is compound event, which means two or more single events. It could be the flip of a coin and a roll of a die. It could be a roll of 3 die. It could be a flip of 2 coins. It could be figuring out shirt and shorts options for the summer. Those are all examples of compound events. Here's example 1. It says Teresa rolls a fair number cube and then flips a fair coin. So a dice and a coin, essentially. Find the probability that the number cube will show an odd number and that the coin will show tails. First, find all the possible outcomes. So we've designed a table here. A cross represents the 1, 2, 3, 4, 5, 6 found on a cube. And the vertical or the down is the heads and tails of the coin. So the one possible combination might be a 1 in heads, or a 2 in heads, a 3 in heads, and so forth. I'm going to put all these outcomes here for our coin when it flips up heads and it pairs with a particular side of the die. It also happens for tails. 1 tail, 2 and a tail, rolling a 3 and a tail, etc. Now, how many total outcomes are there? Well, if we look at this table, there are 12 total outcomes, and we've actually identified what each of those outcomes could be. Now, 3 of these outcomes have what we desire, which is an odd number and tails. Let me show you. Here's an odd number and tails. Here's an odd number and tails. And here's an odd number and tails. So the way in which we can show that probability is probability of odd, comma, tails is 3 over 12. 3/12. Now we can reduce that and simplify that to 1 of 4. There's a 1 in 4 chance that when we roll the cube and we flip the coin, we will get an odd number and tails. Next, the following experiment is going to be performed. We're going to toss a fair coin. We're going to spin a fair spinner, divided into thirds here equally. And then we're going to draw a marble, 1 of 3 marbles from a bag. It's a compound event because it's made of single events. What's the probability that the coin will show heads, the spinner will land on orange, and the red marble will be chosen? So we're looking for heads, the spinner landing on orange, and we're looking for the red marble right there, which I just turned into yellow. So for before we actually list out these outcomes, let me go ahead and remind you of the fundamental counting principle, where we take the number of outcomes of the coin, 2, heads or tails, the number of possible outcomes from the spinner, which is 3 outcomes, and the number of possible outcomes coming from drawing a marble out of the bag, possibility of 3 as well. And what we do with those 3 numbers is we multiply them together. 2 times 3 times 3 gives us 18. 18 total outcomes. What we're going to see in the next slide is finding out what actually those outcomes are. We're going to use a tree diagram. Here it is. We've got heads and tails to represent the toss of a coin. And then we'll go ahead and show you what the possible results would be after we spun the spinner. Well, of course, for each flip of the coin, there would be 3 possibilities with the different colors of the spinner. Add to that the next step, which is choosing a marble. When we choose a marble, all of a sudden, each of these outcomes has multiple outcomes. If we trace this, we can see that in this case, we flipped heads, we got purple on the spinner, and that we've got red drawn, a red marble drawn out of the bag. For a total of 18 possibilities, and they're all listed here. Well, how many possibilities do we have where we have heads, orange, and red? Only one. 1 out of 18. Written, 1 of 18. Now here's your problem to solve this evening. It says Patrick rolled a fair number cube twice. That makes this a compound event. Find the probability that the number cube will show an even number both times. Use a list, a table, which we've seen, or a tree to show your work. All right, we'll see you in class.